You may have heard that the Earth is getting hotter and hotter due to the increasing levels of greenhouse gases in the atmosphere, mainly carbon dioxide. This summer, we have witnessed many extreme weather events around the world, such as heat waves, droughts, floods, and wildfires. These are some of the consequences of global warming, which threatens the stability of our ecosystems and societies. But what if there was a way to reduce the amount of carbon dioxide in the atmosphere and cool down the planet? Well, that's what a team of researchers from Germany and other institutions in Europe have been exploring. They have looked into the past to find clues of how Earth's climate recovered from previous episodes of global warming. And what they found was potentially groundbreaking. I'm your host, Mr. Earth Guy, and you're listening to Earth SciShow. The researchers focused on two events that occurred millions of years ago during the Paleocene-Eocene thermal maximum, shortened to PETM, and the Middle Eocene climatic optimum, shortened to MECO. These were periods when the Earth experienced rapid and intense warming due to massive volcanic eruptions that released large amounts of carbon dioxide into the atmosphere. The temperatures rose by an average of 5 to 8 degrees Celsius, which is comparable to what we are facing today. And upon closer examination by the researchers, they found that there was a difference between these two events. The PETM lasted for about 200,000 years, while the MECO lasted for about 400,000 years. So why did it take twice as long for the climate to restabilize during the MECO compared to the Paleocene-Eocene thermal maximum? Well, the answer lies in a process called enhanced chemical weathering. Enhanced chemical weathering is a natural feedback mechanism that helps regulate the climate. It works like this. When rainwater combines with carbon dioxide in the air, it forms carbonic acid. This acid dissolves rocks on land, releasing minerals such as calcium and magnesium. These minerals are then carried by rivers into the oceans, where they react with carbon dioxide in the water column to form limestone. This process removes carbon dioxide from the atmosphere and stores it into rocks on the sea floor. The limestone eventually makes its way underground, where it gets degassed due to heat and pressure, and it rises through volcanic columns as lava and more gases into the atmosphere. But a key thing here is the time it takes for the limestone to get subducted and then eventually released as gases through volcanic eruptions is much, much greater than it is for the carbon dioxide to get stored in the limestone. Meaning if there's enough limestone trapping carbon dioxide on the sea floor, it can drastically reduce the amount in the atmosphere. So coming back to the PETM and the MECO, why did the PETM have a shorter recovery time? Well, the researchers found that during this period, there was more exposed rock on land that could be weathered by rainfall. This resulted in faster removal of carbon dioxide from the atmosphere and quicker recovery of the climate. Conversely, during the MECO, there was less rock exposed on land and more clay soil. Now, clay soil is a product of weathering that does not dissolve any further. It acts as a shield that prevents more rock from being weathered. This slowed down the removal of carbon dioxide from the atmosphere and delayed the recovery of the climate. The researchers used samples of oceanic carbonates and clay minerals from around 40 to 56 million years ago to measure the rates of erosion and weathering during these events. They also used computer models to simulate how different factors such as temperature, precipitation, vegetation, and soil type affected the weathering process. The study suggests that enhanced chemical weathering could be a potential solution to the current climate crisis. If we could artificially increase the weathering of rock on land, we could accelerate the removal of carbon dioxide from the atmosphere and lower global temperatures. One way to do this would be to spread finely crushed rock on arable land. Here it would dissolve faster than intact rock. Now, for as simple as that solution may be, there are challenges and uncertainties associated with this approach. For example, we need to consider how much clay is formed during weathering and how it affects soil fertility and water quality. We also need to evaluate how effective this method would be in different regions and climates. And we need to weigh the costs and benefits of this intervention against other options such as reducing emissions and enhancing natural sinks. The likelihood is this solution will just be one of many that's required to save the crisis that our planet is currently in. The best way we can combat climate change is by reducing emissions and enhancing the natural sinks. This means ensuring our oceans are fully healthy and absorbing as much carbon as possible, and utilizing more land for rainforests and cutting down on deforestation. Only then will these techniques, such as using crushed rocks on arable land, or even more developed techniques like carbon capture storage, will help. I hope you found this short but informative episode really enlightening. Thank you so much for listening, and please give this podcast a share and a follow. You've been listening to Earth SciShow, and I'm your host, Mr. Earth Guy. And remember, stay curious.